Dear students, good morning. Last class we discussed about analytical instrumentation, unit 1. Right? So there we studied about, recall once again what we studied. We studied about basics of analytical instrumentation, electrochemical instruments like sodium analyzer, silicon analyzer, pH meter, conductivity meter, isn't it? Dissolved oxygen analyzer. And apart from these, we discussed about and spectrophotometer. So there we studied about absorption type and emission type. So in the absorption type we have single beam, double beam absorption spectrophotometer based on the Beach Lambert's law, and one more, what is that? Infrared infrared spectrophotometer, Fourier transform infrared spectrophotometer, and corresponding sources and detectors, isn't it? So these are all covered. And one more, spectrometer other categories, emission based, atomic atomic emission, flame spectrophotometer, that is covered in the previous classes. So that means the chapter 1 of AA, analytical instrumentation, is covered. Today we see the second chapter as per your syllabus, that is which covers about chromatography. Chromatography and NMR. These two concepts are available in the chapter 2, right? And so, what is chromatography? What is chromatography? The word chromatography is defined as the method of separating a mixture of components into individual components. Suppose you can take any compound, chemical compound, we have to separate some ions and chemical elements. So that is the basic idea regarding this the term chromatography includes. We have to take any sample, chemical sample, into the sample, there will be mixture of other components. Just you need to separate each component separately. Each component separately. So that is the main aim of this chromatography. We have to separate the elements or components within the mixture of the solution. That is a process so-called chromatography. So generally this technique is based on differences in the rate at which the components of mixture move through a porous medium stationary phase under the influence of some solvent or gas is also called mobile phase. We will see later what the meaning of this. Generally, this chromatography may be classified into broadly based upon the mobile phase. We are based upon this category. We are doing like this: gas chromatography and liquid chromatography. There are two broad classifications available in this: gas chromatography and liquid chromatography. Okay. So in this uh, gas chromatography, we have other categories: gas, solid, gas, liquid. In this liquid chromatography, we have column, gravity flow, high performance, pressure flow, and thin layer absorption type. So this is the classification of this chromatography, right? And now we are going to see that first of all, what is gas chromatography? What is gas chromatography? And see, generally in this gas chromatography, and this is a diagram that is available. So it is a gas cylinder, and it is a sample injection, is an injector. So we want to inject this sample into this. This is so-called complete column. This is a column. Column is within the oven. So oven is mainly used for uh, heating purpose, heating the column. Column nothing but a is a like container, the uh, long length of a container, so which contains this the unknown sample, right? Yes, and we are placing detector here. followed by any recording or data system is available. So generally in the gas chromatography, the main elements, the main parts available is uh, carrier gas supply. Carrier gas supply is nothing but is a pressure regulator and flow monitor for the constant flow of the carrier. Carrier gas supply means generally see that this gas cylinder provides some gas. That gas is so-called carrier. That is a gas, nothing but carrier. That gas also called mobile phase. Mobile phase. Okay, that's it. And sample injection system. So we have unknown sample that should be injected into the column. So who can inject this? We need some injection supporting system. And chromatographic column. Chromatographic column means this is the blue shape. This is the blue shape is the I'm sorry. This yellow shape is this. Yellow shape is the column. Right? Column is within the oval. Within the oval. And thermal compartment or thermostat. Thermal compartment or thermostat means so we have oven, nothing but a oven. So we need to heat the column as per our requirement at the desired temperature. And one more detection system. So this detection system uh, for identification of sample components as they are moved from the column. So we need to provide some detection system in the detection system. Generally, the detection system not within the oven, maybe outside the oven. Generally, generally it is outside the oven. You want to use. And one more recorder and some microprocessor and digital storage. These three comes under the last part, recording section. In this recording system, data systems, which includes microprocessor, recorder, and display, digital display, graphical display, like this. So these are all available, right? So these are the parts available in the gas chromatography. You tell me once again what is chromatography? We want to separate the components, chemical components in a picture. You want to separate it. How it is possible? It is possible with the chromatography process. Firstly, we see that gas chromatography. In the gas chromatography, how this process is going on means, first of all, we take this. This is called mobile phase. Gas is nothing but, in the gas chromatography, the first word is gas. Gas is nothing but carrier. It is a carrier. It carries the unknown sample. Here the gas is nothing but mobile phase. And what is uh, what is I'm sorry, what is carrier and stationary? Yeah, stationary. So stationary phase nothing but a column. Column column acting as a stationary phase. So it allows the sample to be analyzed and it allows separation of samples within it. That is called stationary phase. So mobile phase is gas. Stationary phase nothing but acting as a column. Acting as a column. Firstly, the operation is like this. First of all, with the available source of gas, like gas cylinder, you apply suitable gas of some pressure, of some pressure. So that is injected into the carrier through along with the sample. So this is a sample. This sample is carried by the mobile phase like gas into the column, into this column. This gas will carry the sample. The sample is injected into the column. So the sample is carried out by gas. So the total mixture is available in the column along with the gas. Okay. So that sample, when it is available in the column, Then what happens? Two things has to be happened here. One is polar, polar and non-polar. Polar and non-polar means the column, the column having a property polar or non-polar, and within the column there will be unknown sample. Unknown sample. If the unknown sample, the mixture having the other properties like polar and non-polar. If the polar, if the mixture is elements having the polar property, they slowly arrive, they slowly reach detector. And if the column having polar and the elements, the mixture elements having the polar, that polar components will reach flow. Will reach flow. Suppose the chemical components within the column having non-polar and your column is polar, so the non-polar elements will reach first. The polar components will reach second, like this, like this. So based upon the this stationary phase property, stationary phase characteristics, the mixture elements will reach the detector. So if the column having polar characteristics, the elements or the chemical components within the mixture having the same polar, they will reach slowly to the detector. But the elements in the mixture having non-polar property, they will reach first to the detector. So like this, first, second, third, whatever the components available in the column, they will reach first, second, third. So that detect after the deviation, you have to represent as a graph. First, second, third. First component, second component, third component. The highest peak of the component will give us a concentration. The second component will reach the highest, the second peak of the component in the graph will give us the second constant of the element, like this. So based upon this graph and this area for each graph will describes as the concentration of the sample within the unknown. Within the unknown. So thereby we can detect the concentration of the unknown sample by this gas chromatography. Very simple. Gas is a carrier, is a mobile phase. So it carries the unknown sample into the column. Based upon the column property, there are the mixture of number of chemical components, right? So based upon the property, one component may reach first, next other component may reach second, third component may reach third, like this. So we have for each component they are representing a line on the graph. A line on the graph. The line shows that concentration. If the line having high amplitude, say high peak, that's the high that's what high concentration. Or the line having some area, that area also refers to concentration. So like this, we can separate the components with this gas chromatography. See the other diagram we are showing like this. The same diagram in detailed manner we are showing like this. See, is a carrier gas supply and two-stage pressure regulator, flow controller, the flow of the gas to be controlled, and is a rotometer. You want see that you want to monitor this gas, right? And and the flow filter it requires, and a syringe detector. So through this we want to inject the unknown sample, and this is the column. This is the column. Column has to be heated by this some heater element, some heater element. So why we need to heat the element means we want to convert the sample. The sample may be solid, sometimes liquid, isn't it? So we want to heat it. We want to convert it into vapor, into vapor. So for the purpose, we want to heat the column. at a suitable temperature, and this is given to the detector that may be electrometer or bridge, or maybe graphical recorder, or it is converted to ADC and data system for other analysis. So based upon the graph, you can say that which element having highest concentration in the mixture. So like this. And what is the second category of chromatography? Second, chromatography. So you will see this in the next class, right? This is about gas chromatography and the components available. This is the basic principle, right? And if you have any doubts, you can ask me. Uh, you can ask me, right? Now I'm going to stop, right?